Hello everyone, welcome. I want to start with sharing one of my biggest frustrations with you. And I want to introduce that by asking two questions, so I would like to see some hands. Who of you does regular code reviews? Say at least once a week. Okay, that's quite a lot, nice. So who of you has ever pointed out common coding guidelines during these reviews? Again, some hands. Nice, okay, I see a lot. Well, this is directly related to my frustration, because when a colleague of mine opens a pull request and I start reviewing, I find myself repeatedly pointing out the same things over and over again. This can be anything, from code style issues, the common coding guidelines, subtle bugs, or some other things that we agreed upon. Well, sorry. That made me wonder, can't we actually automate this? Because I want to not have to spend time manual on this. I want to spend time on the things during code review that are way more important. So, my name is Ossendrijver, and today I'm going to show you how we can actually start automating this problem. The title of the talk is Automating Away Bugs with Error-Prone in Practice, and Error-Prone is the tool that we're going to use for this. So, I'm a software engineer in the Java platform team at Picnic. And Picnic is an online grocery store based in the Netherlands, and we are active in 3 countries, namely the Netherlands, Germany, and France. We're currently in the scale-up phase, and we have over 300 developers. So, let me go over the agenda. First, I will give a little bit more context about Picnic and some of the processes that we have, especially resolving around code quality. And after that, I want to introduce to you Error-Prone. Then I want to show you how you can actually start using Error-Prone in your code base, because that's actually the goal of today's talk, that you're able to walk away knowing how you can introduce this tool in your code base. And after that, I want to show you how we use it internally within Picnic, and I want to share some lessons learned and some valuable insights. So without further ado, this is our app. Customers can use the app to buy their groceries, and then we have electric vehicles. On the right you see a picture of those. It's a cartoonish version, but in these vehicles we deliver the groceries at your doorstep. Of course, this is all the customers see, so the app and the person who does the actual delivery. But in order to manage this whole system, we have a lot of code, and we build all our code in-house. And we have the goal of becoming the online supermarket in Europe, so we still need to heavily expand. We need to write a lot of code, and we also need to review a lot of code. So we at Picnic believe that that in order to achieve that, we need a really excellent code quality. When I hear someone say code quality, I always need to think about this image, where the amount of WTFs per minute gives a very clear idea on how good the code is that is being reviewed. But kidding aside, what do I mean when I say, hey, we are really striving for an excellent code quality? Well, of course, we need a really good architecture. We need to have an extensible and really flexible setup. And one of the things that we do have in place for that is, of course, the review process. We're very strict with all the things that we do allow, and we are really focused on making sure that the code that enters our code base is really consistent and has the least amount of possible bugs, because that allows us to adapt quickly, create new features while maintaining our current stability. But as I said, we still need to write a lot of code, a lot of reviews, so we believe that automation can play a key factor here. One of the goals of this automation is that we want to limit the amount of bike shedding that is happening, especially during these code reviews. So bike shedding is a term for wasting time on discussing trivial things, while you should actually focus on the things that are way more important. So we do not want to discuss the color of the bike shed, but more like the features of the bike shed that are really important. So let me give you an example of that. So let's say a colleague wrote some code. He changed, in this case, a very specific method, string.isEmpty to string.equals, which are both actually do the same, but someone reviews the code and says, hey, I see we changed method A to method B. Why are we doing this? We agreed on using method A instead of using method B. And you see there are 3 upvotes on this comment, so this can easily trigger a whole new discussion in this pull request. And that is exactly something that we really want to prevent from happening. It's of course a simple example, but things like this happen a lot. So it is okay to have this discussion, but you need to have this discussion once. You need to settle on something, and then you need to make sure that it is enforced over your whole code base, such that the bike shedding discussion cannot happen again. So we have a few different tools in place to help us with limiting this bike shedding that is happening. One of the easiest is of course using a formatter. Internally we use the Google Java format. It's a fairly opinionated formatter, so there are no discussions possible about where to put the curly bracket, either on the same line as the class definition or on a new line. So another type of these tools is the static analysis tools. So for example, SonarCloud, CheckStyle and Spotbugs. These are the industry proven best practices. We also use them internally, but we really think there is a limitation to these kind of tools. Take for example SonarCloud. If you open your SonarCloud dashboard, it almost directly screams at you, hey, you have over 40 days of technical debt. And you're like, yeah, but I'm working on this high priority feature that has to be done actually yesterday, so I have no time to work on this technical debt. So what happens in practice is that this technical debt is just there and is left untouched. And we think this is a really big limitation, so we wanted to go actually one step further. And that's where we are going to my favorite part, because here I get to say, allow me to introduce you to Error Prone. So, Error Prone, oh, it's back again. Let me unplug, okay, well. Error Prone is a tool open sourced and created by Google. It's a static analysis tool for Java, so it can find and detect bugs in your code, but it can do much more. Because it still has a link to the actual source code, it can provide a suggested fix for that bug. So, and what's even more interesting is that you can run Error Prone in patch mode, and then it will automatically apply those suggested fixes for you. So how does that work? Well, Error Prone is a compiler plugin, so that means that we start with a Java class, the compiler starts compiling, and starts to gather a lot of extra context, a lot of extra checking, type resolutions. So there's a lot of extra context available, and right after that, Error Prone kicks in and can use this extra context to do a way more thorough analysis than most static analysis tools. And the cool thing is that when Error Prone finds something, it still has the link to the actual source code. So it knows how it should update that bug in your actual source file. So let's say you start enabling a specific check of Error Prone. You run it in patch mode over your whole code base. It finds all the violations and it will fix all the bugs for you with only one run. That's why Error Prone is a really powerful tool, especially when you know there are over 500 Error Prone bug checks. You can of course configure them just like how you want them to be. There are always some bug patterns that do not really work for your code base. There are 3 types of severity, so you have error, warning, and suggestion. But there's one downside to Error Prone, and that is that it is quite complex to create your own rules. For those of you who know, you have to work with the abstract syntax tree, and that can be quite complex. But the guys at Google thought about this, and they wanted to create a way in which you can more easily specify refactorings. So they created another tool on top of Error Prone, and that tool is called Refaster. So Refaster is a tool with which you can specify refactorings using before and after templates. In the before template, you specify what code you want to match, and in the after template, you specify to what code you want to rewrite that. Let me give you an example. So we see that we have a before template here and an after template here. And how this works is that we say, hey, we want to match any arbitrary string expression, and that will go in here, and then it will be matched against the equals. And again, if we run this in patch mode over, this is an example, so Here we have indeed an equals on some string field, and if we would run this in patch mode, it will get rewritten to the content that is specified in the after template. And then it will become .isEmpty. So as you can see, this is a fairly easy way of specifying a refactoring. There is one downside to this, however, it only works on expressions and statements, which generally means only things inside method bodies. So, now that you know error-prone and refaster, I want to actually do a demo. But before we go to the demo, I want to do some additional explanations such that you can understand what all the things are happening. So, for the demos, I will use a Maven project, but please note that error-prone also works for other build systems like Bazel, Gradle. And there's here a link to a GitHub page of the demo. It will also be in the final slide for reference. So we will work with a normal Maven build, and we will apply 2 profiles on top of that to enable additional things. I'm going to show you those. So the first one is the error-prone profile. So we say, hey, we have a profile, name is error-prone. So if we have a Maven clean install, we say, hey, -p error-prone, and then we enable this additional configuration. And it means that, hey, we have a Maven compiler plugin, and here we have an additional, here we can provide arguments to configure error-prone just how we want it to be. So we have the X plugin error-prone means that we enable it, and here is a simple example of how we disable a specific check, namely the Java 8 API checker, because we don't target JDK 8, and we can here override the severity to off. So the second profile will be used on top of the error-prone profile, because that is the patch profile. What we say here is, so the patch profile saying, hey, I want the patch location of the suggested fix to be in place. And that means in the actual source file, so it will update the code for you. And you can provide patch checks, which allows you to specify which checks you want to run over your code. Can be either a specific check, but as the comment shows, it will default to the empty string. So then it will run all the checks for you. Okay, let's go to the demo. Okay, so we have a really simple class, and I want to ask you to spot any things that can be improved. So in every method, there's one thing that is not optimal. It might be improved. So if you have any ideas, raise your hand or please shout. Sorry? Missing throwing. Indeed, we have a new illegal argument exception, but what does it mean without throw? Good one. Other options? Is empty. Good one. We saw that one. .length to .isEmpty. Last one. Otherwise, we're going to ask error-prone to take a look. Indeed, line number 17 is not needed. Well, as you can see, I already prepared the command. So we do a Maven clean package and then the error-prone profile to run error-prone. And we're going to see if the things that you brought up are the correct things. So what we see is that error-prone indeed flagged some things. So it says, hey, on line 21, a refaster rule had found a violation. It says, hey, did you mean return string.isEmpty? Well, indeed. Another one is the dead exception on line 10. So it says, hey, exception created but not thrown. Did you mean throw new illegal argument exception? So this is the suggested fix that it provides to you with a clear message. And there's also like a link to the actual documentation of error-prone, which allows you to see some extra information about it. And the last one is indeed the copy of. It says, hey, this method invocation appears redundant. Did you mean return set? Well, the cool thing is now that we, of course, could fix this manually, but we want to use the second Maven profile, saying -p patch. We run it again, and if I click here now, then indeed we see that the throw is added, the copy of is removed, and we have a .isEmpty. So this is, of course, on a simple file, but this can then run over your whole code base, fixing all these violations for you. A question I often get is, hey, can we maybe suppress something? Let's say I really want this copy of here for a reason. Well, of course we can have, like, if we encounter a really specific edge case because of a reason, we can just say, hey, suppress warnings, and we say identity conversion, and then it should not flag it. I will run it again, but note that we also have a nice refoster rule that optimizes this, so please pay attention there as well. We run the patch, and if I click, we see indeed that this is now a check argument, which does the same but is shorter, and the copy of is just there like before, because of the suppression. Okay, so those were fairly trivial examples. Now I want to give you some more examples of what error-prone can do, and also some more, some more rules that which allows us which makes us think that error-prone is really a superpower to use. Okay. So there's a list of all the bug patterns on the error-prone website. For all the 500 checks, there is some information. And I'm now going over a few specific ones. So let's say you have a sorted collection in your code, and there is a type that does not actually implement the comparable. Then you're probably doing something wrong, and this is a bug. So error-prone will flag that for you. Because of this additional context, error-prone can identify instance of usages that would actually result in a null check, and will flag those as well. Another one is the constant field bug pattern, where it will find fields that are named like with the constant case, following the constant case pattern, and those should probably be static and final. For the attentive viewer might say, hey, this is something checkstyle can also do. Well, that is true, but remember that error-prone will automatically fix this for you, where checkstyle doesn't. So this one requires a bit more explanation. So I assume that in almost every team, there is a person who's really a fan of immutability and is really keen on making sure that it is really clear when something is immutable. So in all the methods, if there is a constant variable, it says, hey, we need to add the final keyword because it is a constant variable. Well, I highlighted here the examples of the places where you could add the final keyword. The variable bus is used down here, so that one doesn't need one. So if you have this focus on the immutability, your code base gets quite cluttered with all these final keywords. But what if we can change the default from a variable being mutable to immutable? We can drop all the final keywords. Well, error-prone has a bug pattern for this. It's called the var bug pattern, and it says, hey, non-constant variables should have the @var annotation. So this way we can flip the default, because we say, hey, if we see a local variable, we assume it's immutable, and when it is not, then we have to add the @var annotation, which omits the need of all these final keywords throughout your code base. And the fact that error-prone allows you to completely flip the default like that is really powerful. And another one with which error-prone can really help is, sorry? The difference is that you now don't need the final keyword everywhere. And the default is immutability, which is usually the preferred one. Yes. Because error-prone will make sure that if you have a variable that is changed, it will say, hey, you need to add the @var keyword here. So it will also automatically control that for you. So another thing with which error-prone can really help is usages of APIs, and also migrating usages of APIs to improve those. For example, the optional.get, when everyone started using that, everyone started introducing usages of optional.get, but then later the URL throw was there, and usually it's like, okay, we need to either manually go over all these changes and move to the URL throw, which is costs time, and because it's manual work, people also tend to forget some of the usages. Well, if you create one refaster rule and you would run it over your whole code base, and yeah, all the usages are automatically fixed for you, and you save a lot of time, and you do not forget one. And yeah, this is of course a very simple example, but you can do this for every kind of API usage that you want. So now that you know what error-prone is, I'm going to show you how you can actually start integrating it within your team or within your company. And this can be quite a complex thing, because if you would say, hey, I introduce error-prone, we enable all the 500 rules, yeah, your whole code base would get rewritten. No one would want to review such a thing, let alone getting that to production or dev like in a timely manner. So I'm going to show you a roadmap of how we can yeah, slowly start with this. So we're again are going to use the two Maven profiles. So we have our normal project, normal build, and we enable the two profiles, and we configure error-prone in such a way that all checks are disabled. But because of these two profiles, we are able to at least run error-prone for specific checks. So, and that is exactly what we're going to do. So when we're on level 1, we start running a command to say, hey, I want this specific bug pattern to run over our code base. And here, before you do so, you really need to think, hey, what is a bug pattern that my team will really like? Like, what is a very clear improvement and will fix a bug that occurred in our code base multiple times, maybe? Because if you would run something like that and you would say, hey, can you please review my code? People are like, hey, this is something that that brought us into problems quite a few times. Now it's automatically fixed. Thank you for that. And they will be glad to review such a thing and merge that. So, and that is a process that you need to do quite a few times, because you need to specifically enable quite a few bug patterns and ask for these reviews, and people need to get into the habit of actually reviewing these type of pull requests. So after you've done that quite a few times, and the team is really liking error-prone, yeah, the goal is working towards a point where you enabled all default error checks, because then you reached a really nice milestone if you didn't use error-prone before. It sounds nice, but how does it actually look? Like how would you do that? Well, I prepared a demo for that to make it a lot more clear how we would run such a check, and I want to really show you that it's actually quite easy to review changes like this. So I went on GitHub, looked for a nice open source project, and I found one. And yeah, this project really could use some error-prone. Like there were quite some unnecessary final keywords. They didn't even use a formatter. Had a lot of unused imports. So what I did, I cloned the project. I added the formatter, ran the formatter, and of course added the two Maven profiles such that we are at the baseline, namely level 1. And from there, we're now going to actually, I'm going to show you how we can go from level 1 to level 2 by running one specific bug pattern on the code. So we do almost exactly the same as before. We have the error-prone profile, we have the patch profile, and here we use the specific patch checks argument to say, hey, I want to run a specific bug pattern, namely the unnecessary final. And yeah, it's actually as simple as that once you have the baseline. And yeah, now I can just press enter, but I'm not going to, because if I would, it would compile all the whole code base, and it's quite a big code base, so that would take quite some time. But I of course prepared a commit that I can cherry pick, so I have an alias for that. Yes. So this is the result of applying this bug pattern on the code base, and what you can probably see is that there are almost 800 files changed and over 4,000 lines have been changed. So that is quite a lot. And yeah, we can now simply push the result of that. And now we're going to inspect these changes in GitHub. So as you can see, one bigger. Is this readable? Okay, good. So indeed we have the patch unnecessary final bug checker. And what I want to show you here is that the result of applying a single check is actually quite simple to review. because the changes are really similar. And once you're going over these changes, your brain is just pattern matching, and it will be very clear when something is strange, like when a weird thing happened. And yeah, there's a really low false positive rates because that's really the focus of an error-prone check. So you can be quite sure of the quality at some point, and yeah, you can just easily scan over the changes and yeah, point out the things that you find, and then you can just approve. So it's actually as simple as that. Like after we went over the changes, we can just say, hey, create the pull request, you ask the others to review, and you get into the process of this. I see there are 4,000 lines changed. To be honest, I would maybe split it because it's a bit big, so 2 pull requests would maybe be better, but still, you get the idea. So just to reiterate, it was simply from level 1, and this is the part from level 2 that we have to keep reiterating. Okay, so now that you know how you can start using it, I actually want to give you some insights into our usage of error-prone at Picnic. So we have a lot of Java repositories. In total, we have over 50 Java repositories, and all these repositories have one common parent. And in that parent, we have the configuration of most static analysis tools that we use at Picnic, for example, error-prone. And we also provide in every code base a patch script. And that patch script actually uses the 2 Maven profiles. If you invoke it, it will do a full build, and it will add the error-prone profile and the patch profile, which means that if you write some code, you can run the patch script over your new changes and see if you have any violations or your code can be improved. So you get direct feedback on the code that you write. And this setup is really convenient for our CI, because we set up our CI in such a way that if you create a pull request, there will be a lot of extra analysis, and this patch script will be applied too. And if the developer wrote some code, did not run patch themselves, the CI will do it for them. And if there are changes, it will say, hey, it will show you an error saying, hey, there are changes. We use a tool called Danger for this that executes it for us. And the developer sees this and has to inspect the result by himself. So check out the code, run patch, and see the actual changes, because we do not want to auto-commit this. It's always important that the developer stays in control and actually checks, hey, what is happening? Do we agree with this change or not? And if this error is here, it's simply not possible to merge, which has a really nice advantage, because once you enable a specific bug pattern in your code, you can assume that this bug will never enter your code base again. And that's really powerful. So I think by now it's clear that we at Picnic are quite fan of error-prone. So at some point we thought, hey, we actually want to do more. So we created a repository on our own. We created a lot of extra rules that we wanted to apply on our code base, and we created some extensions for error-prone as well. And at some point we thought, hey, this is actually quite valuable for the rest of the community. And at Devoxx Belgium last year, we actually announced that we open sourced the project. So we open sourced error-prone support. On the right, you see our mascot. It's Cody, the Codebuster. And in this repository, we have over 750 refoster rules and over 40 error-prone checks. And yeah, it's a Picnic set of opinionated set of rules. So we really focus on consistency, API usage, and really drive that to the next level, push that to the next level. And I will show you a few examples. Like this is the one we saw where we have the simple if condition, throw new illegal argument exception. We want it to be more concise, and also if there are 2 ways of defining one and the same thing, we actually prefer to have one consistent way of doing so. So there we have this refoster rule, and we also have quite some bug patterns where we really focus on correct API usage. So for those of you who know Reactor, here we have a flux, and on that we call a flap map. And the thing here is, if you pass only one function to the flap map, what actually happens is that implicitly there will be a concurrency set. But for the developers that are not well versed with Reactor, it's actually they don't know about this concurrency. So we had quite some issues with that. When debugging some issues, it was like, oh, where is this coming from? Well, because of this implicit concurrency. So what we say, hey, if you're using this, you probably want to do a normal concat map. But of course, if people really want to use this concurrency, that is also fine, but they have to explicitly define this. So we say, hey, we disallow this specific overload, but if you know what you're doing in this case, then you can just specify a concurrency, and then it's really clear what you are actually using. This is a way of guiding people in using APIs. Another one, oh, there's not another one. Some other features that we added on top of error-prone, that we made it a lot easier to run refaster rules. The support from error-prone itself is not that easy, but we made it easy to run a lot of them in one go. And we also introduced a test support module for the refaster rules, because it's really convenient if the refaster rules are actually rewriting how you want them to rewrite things. And during the demo, we saw that the refaster rule actually showed something in our command line. Well, that is something that out of the box refaster rules can also not do. We created support for that in error-prone support. And we also have a documentation website that I'm going to show you. So this is the homepage where we have our README. And if one of our bug patterns flags something in the code, it will actually point to our website. So it will give you some examples, like here are some examples and explanation on why we have this specific bug pattern, and it will show the things that it will actually flag to give you an idea of what you're actually looking at and why you should improve your code. And we also have the same then for refaster rules. Let me show you an example of, that shows why we really love consistency. So instead of having multiple ways in checking whether something is empty, we say, hey, we rewrite everything to almost one and the same thing, namely the .isEmpty operator. So when we created this repository and started adding all these rules, they were not directly enabled by default in our build. But at some point we had so many rules, we thought, okay, hey, we really need to start applying these to all our repositories. But as I mentioned, some of these rules were rather opinionated. So we needed to verify if all the developers at Picnic were really a fan of these rules and whether they really agreed with them. And also if there weren't any edge cases that we didn't think of. So we needed to really verify that the things that we created were actually correct and appreciated by the other developers. So at that point, we actually had to make a plan. How are we going to do this? How are we going to test this out? Well, we started creating pull requests in all in the repositories of other teams, and we created over 60 pull requests. And you see some of these numbers. It gives you an idea of the size of the pull requests that we made. Based on these numbers, I think you can imagine that this boosted my GitHub stats quite a bit. In total we had over 33,000 lines of code changed because of error-prone support across Picnic, which is really nice. You might wonder, okay, you made these pull requests, but how did you approach that? Because again, just opening a pull request saying, hey, this change can be one of these 750 refaster rules. Well, that's not convenient. People are not able to give proper feedback, and it will take quite some time to review this again. So what we actually did, we made a nice pull request for them. We splitted the changes on like very specific topics, saying, hey, these set of rules is responsible for these changes, such that developers could way more easily say, hey, is this actually correct? Again, if the changes are really similar, it's a lot easier to review. And sometimes it meant that we had to split the changes over multiple pull requests just to make it easy for the rest of the developers. And of course, when they gave some feedback and said, hey, why are we doing this? Why are we doing that? Like, I'm not sure if I agree on this. We really took the time to make sure that that they felt heard, and we give a proper explanation as to why we are doing this change, and try to address their concerns. But of course, we have quite some developers, and there are also some really opinionated developers, which is a good thing. But yeah, at some point, for some specific rules, we noticed quite some feedback or pushback from the developers saying, hey, I'm not sure if I like this. And because we did it in many repos, it was really clear when something was like too big of an issue. So in that case, we actually wanted to get the opinions of all developers. So what we did, we created a poll on Slack, for example. This is an example. So we would explain, hey, this is the issue. We have these are the advantages, disadvantages. Please give your opinion, and yeah, make sure you cast your vote or raise any additional concerns. And in this case, it was about the local time, where there were 3 ways of defining one and the same thing. Well, yeah. The developers were really happy with this because they were really part of the process, could really have an influence on the result, and they because we asked for their opinion, they were generally really happy about this. For most developers, it was also like, hey, as long as it is consistent, it is totally fine by me. Like, I don't care that much about whether it's method A or B, as long as it is consistent and enforced over our whole code base. Well. Yeah, let's talk about the current state of error-prone support. I'm happy to say that by now all our refoster rules and bug patterns are by default enabled in our build. But I want to get back to the beginning where I said, hey, we are really focusing on making sure that we can automate parts of the code review process. So it was not really our goal to write like the big book of Picnic and saying, hey, this is how you need to write code. We, together with the developers, wanted to create a way which we can really help them writing code and automating things. So we needed the other developers to come with their ideas and saying, hey, it's now the 4th time I'm writing this comment, please automate this for me. Well, it even gets better. We really wanted other developers to create pull requests in error-prone support. So we really needed to incentivize other developers to do this. So we used a really powerful mechanism for this, and that is that we created custom stickers. And that worked quite well, so the developers were really happy with this. And yeah, we got in a few months' time, we got over 30 contributions. And yeah, they were really happy with this because when they created the pull request, within about a month, this rule would be applied over all Picnic code, and they would never have to worry about it again. And yeah, as for the external adoption, I can say that Checkstyle and an open source repository of Uber already applied our checks, and another popular caching framework, Caffeine, created by Ben Mains, also uses our prone support checks. So, yeah, a small conclusion. I can say that the developers are really happy about the fact that we introduced this, and of course, because they can really be a part of it and have a direct impact on the code by themselves. But it's really important as a platform team or the people who maintain this configuration that they really focus on making sure that the changes they introduce are actually correct and people are happy, that they do not think that they do not agree with the changes. Because if you then continue to push, people will push back and they will just not upgrade or not use it anymore. So you need to really think about the changes that you introduce. And yeah, if you're excited about this or want to read more about this, you can see our blog or the website to join, with information about joining Picnic. And yeah, with that, I want to go to the final slide with some links for example, the demo, the website of error-prone support. And I want to give a special thanks to Stefan Schroevers, who is one of the founding engineers of Picnic. And is really responsible for this error-prone mindset within Picnic and also created error-prone support. On the top right, there's a QR code for that goes to error-prone support. And with that, I actually want to thank you all for your attention.